Okay, what I want to do is show you a short review video on how to solve a polynomial that's cubic and of 4 terms. And what we're going to do here is something called factoring by grouping. No matter what kind of a problem that I'm giving you, if I want you to solve it, I want you to always start off your problem with your equation equal to 0 and in standard form. That's the best method that I can give you. So we're going to start off using that. I'm going to move everything to the left side of the equal sign and get it all equal to 0. So that's my first step always. So minus an x squared from both sides. And I'm going to add an x to get rid of that. This side will cancel, and I'll have it equal to 0. The other side will just simplify. I'll still have my 2x cubed. I'll have a negative x squared. 17x plus another x will be an 18x, and a negative 9. At this point, what I would typically try and do is I would try and find a greatest common factor. I always try and do that first, but in this case, there isn't one that's common to all 4 of those terms, so that I can't do. What I'm going to try after this is I'm going to try factoring by grouping. That's the next easiest method for factoring a polynomial that looks like this. So I'll group my first 2 together, and I'll group my last 2 together, and I will factor this similarly to how I did it when it was quadratics. I'll look for the GCF in the first set of parentheses, which in this case, there's an x squared common to both of those 2 terms. So I'll factor an x squared out, and I'll be left with a 2x and a negative 1. What I need to do at this point is factor something out of the second set of parentheses that will leave me with that same 2x minus 1. If you don't have the same thing in both sets of parentheses, then this method is not going to work for you if you're trying to factor by hand. So I want to make sure that I have that, and if I don't, I'm going to have to figure out something else. But in this case, I can do it very easily. In that second set of parentheses, if I factor a 9 out of both of those things, then I should be able to get what I want. Now at this point, I'm going to take my 9, and that's plus, by the way. That's still plus sign. And my x squared, and I'm going to make that into its own set of parentheses. This part here is going to be the other set of parentheses, so I'm just going to regroup this. And so I'll put my 2x minus 1 in front, and I'll take my x squared plus 9 second. This is all still equal to 0. At this point, I'm going to take my linear factor that's here, my 2x minus 1, and set it equal to 0 and solve, and I can do that because it is in fact linear. Everything in that set of parentheses is to the power 1. And then I just solve. And that one's done. This other one, I'm going to have to do a little extra work on. If I had that something squared minus something squared thing, then I'd be able to use something called the difference of perfect squares to factor this, but I don't. What I'm going to do is I'm going to take this x squared plus 9, and I'm going to try and make this into something squared minus something squared. It is something squared plus something squared, but if I can change this right here into a minus sign, then I am going to, and then I'll be able to factor this using my difference of perfect squares. Please remember that an I squared from chapter 4 is equal to a negative 1. So what I can do is I can put an I squared on to my 9. If I do that though, that's going to be a negative 1 attached to the 9, and that's going to end up making this part right here into a negative as well, and so it changes things a little bit. I'm going to rearrange this now, and now it's going to look like x squared minus 9i squared. This factor now can be factored using the trick that I showed you with the difference of perfect squares. The square root of x is x, so I'm going to put that first in both sets of parentheses. The square root of 9i squared is 3i, so that goes second, and then I just alternate my signs. Now I've got a linear factor and another linear factor, and just like before, I can set each one of these equal to 0 and solve. And I've got all three of my solutions. I have this one, and this one. I hope this little review helps. Good luck.